All right. So this video is for you, Raya, and you, Jace, because I told both of you that I would give you some resources and things like that. But however, some of the resources I know with you, particularly, Raya, I showed you some videos, and that was bad on me. You looked at it and thought it was too complicated, too complex, and I thought, you know what? He's right. Those videos were for someone else. So what I'm going to do tonight is I'm going to go through some of the easier ones, especially with a really great website that I think you guys would really like. And that website is, I'll start from the very beginning, KicoCTF.org. And what this is, Carnegie Mellon University, they put out this for mainly for middle school and high school students to kind of see if they like the hacking world. Practice, visualize, blah, blah, blah. We go to login. I even learned from it a little bit here. In the categories, you have difficulties, you have categories here, web exploitation, cryptography, reverse engineering. We are going to focus on binary exploitation. The reason we're going for binary exploitation is because really it's the foundational piece to which exploitation occurs. If you think about web exploitation and things like that, well, all that is exploiting a program out there. It's a little bit different flavor, but it's still kind of the same fundamental things. So we'll do binary exploitation, and we'll do one of the most common, famous ones that sometimes is still even used today, the buffer overflow. And so here we say, let's start off simple. Can you overflow the correct buffer? And all a buffer is, so if I bring up the terminal, so see where that pipe is flashing? That right there is a buffer. And I can put a bunch of Ks in it. I can put a bunch of Js in it. And if I do too many, I do like hundreds, thousands, whatever. Sometimes the programmer, the software engineer who wrote the program, sometimes they didn't do a very good job writing the program. And so you can actually exploit it by overflowing the buffer. And so that's the general idea for that. So here is buffer overflow 0. We are going to go ahead and launch the instance. And what this is doing is it's creating a server out there in Pico CTF world that you can connect to. So if I take this NC blah, 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 Saturn, whatever, and I copy and paste it into my terminal, all right, that input, that's coming from them. They wrote a program that is vulnerable and it's got input, blah, 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 and then I can just write stuff to it. The program will now exit. So kind of boring program. All NC is netcat. So if I do netcat like this, I get the same thing. NC is just short for netcat. And netcat is a tool. Saturn, whatever, all that stuff is just an address. And this is the port number. So there you go. Now we're going to, the program is available here. This is the program that we're going to hack into. There we go. All right, so as we can see, Vuln 3 here, we're going to go ahead and change its name to Vuln. There we go. We'll go ahead and run the program as well. Let me get the terminal back up. All right, so let's see what Vuln does on my system. Probably does the same thing. Oh, okay. It gives me this, says, please create this. Okay, gotcha. So I'm going to create a text file that says flag.txt. So I'm going to go, hooray. There we go. I'm going to save it as flag.txt on my desktop. All right, so now we see there's the flag. So let's try running the program again. Okay, this time it gave us something. It gave us exactly what we've been seeing going towards the server. And so what that means is this program in the code, it's saying, hey, I'm looking for a flag. If you do something bad to me, you know, correctly, then I'll give you the flag. And when you're dealing with these CTFs, these capture the flags, which is what this website is, it's all CTF, all capture the flag. In the hacking realm, the flag can be anything. The flag is files, blueprints, crypto wallets, The flag could be permissions. The flags could be control. And so when we exploit programs, we're trying to quote unquote capture the flag, but that flag could be defined by anyone. Could be defined by generals who are like, hey, the Americans have blueprints on a new fighter jet. I want you to hack into the United States and get those blueprints. And so hacker goes, okay, I'm going to do it. He does it, up, capture the flag, blueprints. So that's the whole idea behind capture flag. All right, so now we're going to actually look into this program with an overflow attack. I'm going to go ahead and look. Let's see here. Let's do GDB on Vuln. There we go. Actually, before we do that, let's take a peek at Vuln. All right, so boom, Vuln, Intel flavor. Okay, right here. And what we're looking for here, okay, there, the main function. So in every C program, or not every C program, but usually most C programs, you have a main function. And within that main function is basically that's the beginning of everything you do. The main function here, it looks like it's got a few calls that we'd be interested in. Here, the F open. Okay, so this F open file open, that's the one where it's looking for the flag file. All right, let's see what else we got. Bunch of gibberish here. Okay, gets, that's probably the vulnerability right there. Let's play around with it. Let's see what happens if we just kind of overflow the buffer. Ah, look at that. So I just overflowed the buffer. That's your standard overflow buffer attack. And there is the flag. So whenever we overflow the buffer, that flag gets read. We get the blueprints. All right, so now I know what to do. So now what we could do, instead of attacking Vuln, we can attack Netcat right off the bat. So let's do lock and lock. Go back to it, do a bunch of Ks just like before. All right, there it is. This is the flag. We have captured the flag. I copy it, I put it down here into the little field, press enter. Hooray, you have solved this challenge correctly. Again, because I've done it a few times. All right, so that is the whole point of this website. You open up a challenge, you try to hack something that it tells you to hack, and if you do well, it gives you a flag, and you can check that flag against the field. So now let's move on to buffer overflow 1. So this one says control the return address. Okay, let's see here. Let's launch instance. You gotta wait for it. There we go. And we're going to go ahead and get rid of some of the stuff that we had. We won't get rid of the flag because I already know that they're going to be looking for that again. All right, so boom. Here is the program right here. Okay. So this is a new program that we're trying to exploit. Yeah, rename it Vuln. Here's something too. It says you can view the source here. I'll just show it to you, but don't worry about learning it right now. It's really nothing to look at you guys' level. All this is the C program, and the C program that is behind all the stuff that we're doing. So see, it says, please create the flag in your directory. We've seen that before. I created the flag, then it was some kind of input or something. Now, because this is a different program, this is actually going to start out with, it looks like, please enter your string. So we'll test that out. We'll just play around with the program real quick. All right, same way as before. We look at it. Please enter your string. Okay, file. Okay, time to return. Fingers crossed, jumping to 804932 Foxtrot. Okay, let's see what happens when I do it again, but a different word. 804932 Foxtrot. Interesting. Okay, so it kind of looks like every time it's going to give me that 804. Let's look in here. Okay, time to return, fingers jumping to this, and then they have a function called get return address. Ah, that's interesting. So what it's doing, that is the actual return address. that the function bone is jumping back to. All right, so we're going to check this out real quick. I'm going to examine the binary. Okay, here we go. So we go back to main. Here's main. And within main, let's look for that 93.2 Foxtrot. Okay, here we go. Look at this, Vuln. So there's, okay, here's the Vuln function, and here it is being called right here in main. And sure enough, after the call to Vuln, it's going to return to 804.932 Foxtrot. Okay, good. So now what we have at the moment is a solid return address, right? Return address equals 804.932 Foxtrot. All right. So that's where the program is trying to jump back to after it executes the vulnerability function. All right, let's look up. Okay, here. So I already knew to look for this. In a lot of the elementary hacking CTF, they have something called the win function, WIN. You won the game. And what this function is if you can get the program, instead of returning to where it wants to return to, if you can divert the program process to go to that win function and execute that function, you get the flag or the whatever. And so in this case, this is the win function, and this is the address at which the win function lives. So we're going to take that. We're going to have our handy dandy notebook. Boom. All right, there we go. Target. So now we have where the computer wants to go, and we have our target. And so we're going to try and get the computer or the system to go at that target. All right, there we go. So now what we're going to do is we're going to use another tool. So far we've used Netcat, we've used Object Dump to kind of look at the guts of the program, open its body up and look how it works. And now what we're going to do is we're going to use GDB. BDB is GNU Debugger. And what you do is you take any kind of binary or many of them, and you can use GDB to try and basically stop the program in its tracks and then cause the program to take baby steps so that you can see how the stack works. And so when I've been saying buffer overflow, the buffer is that little input blinky thing. Okay, that's the buffer. You're trying to overflow the buffer. But the reason that you're trying to overflow the buffer is because every program in the computer system, it runs in a stack structure. And if you can overflow the buffer, what you're really doing is you're overflowing the stack. And so you have the buffer that's on the stack. And right after the buffer, in most cases, you have the return address. And that's what you want to overwrite. So you want to overflow the buffer like this. And then at the end, put in the target, which is 804, like 96, whatever it was. Put that at the end. So that way, when the computer gets through reading all this stuff, it's going to return to this instead of the 93.2 Foxtrot or whatever. So anyway, we're going to try it out. All right, let's go ahead and GDB on Vuln. All right, we saw the function main. So I'm going to break on main. And then I'm going to go ahead and tell it to run. It is now inside the program processing. I'm going to tell it to kind of step through. And NXE is a program that I wrote to kind of show us the innards of the stack. And so as we're stepping through, you can see how right here is where all the processes are being stepped through. And this is the state of the stack. All right, so as it's going through, set, I'm going to go ahead. Let's see here. Keep going. All right, the puts. We would love to guess what that puts is. And I bet you $1,000,000 that puts right there, when we step on that function, we're going to see the please enter your string come up on the screen. Yep, there it is. Boom. So please enter your string. We've seen that before when we ran it. And so now we're going to keep going. Looks like it goes into the call to Vuln. All right, interesting. And then I'll put some Ks because it's asking for the input. Okay, and then it says, okay, time to return, jumping to 93.2 Foxtrot. All right, now the program's pretty much done running. I need to step inside Vuln because all we did, we went through the processes that were only for main. Well, now when I get to Vuln, I want to step into that too and slow it down. So it's kind of like if you've ever seen the movie Inception, we got to go within the parameters, within the functions inside the functions. So I'm going to go ahead and run this from the beginning again. As you can see, we're going back down the list. Here's that puts. It's going to say, please enter your string. Boom. And now I'm going to step into Vuln. So I'm going to SI into it. Now we're inside Vuln. And as we go through Vuln, here's the gets function. So this gets function is going to say, hey, give me some strings, give me some characters. And so I'm going to give it some characters. I'm going to give it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I just gave it 12 Ks, which if we look on the stack, so note what the stack looks like at the moment. Here's the 93.2 Foxtrot. Somewhere around here, the Ks are going to show up. So I'm going to do this. Yep. And there they are. So the reason, so you may say, hey, those don't look like Ks to me. Those 6 bravos are the hexadecimal representation of the character. And so when you see 6B together on the stack, just know, oh wait, no, those are my Ks. And I put like what, 12 of them? Yeah, look at that. 12 Ks right there. Because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I know exactly where the buffer begins. The buffer begins right here. So all I have to do is calculate how many Ks in order to get to this 93.2 Foxtrot. All right, so I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so 11 Ks is what it takes to get to that return address. So I'm going to note that in my notebook. So the overflow that I'm going to create, okay, times. So we counted 11 sets of these Ks. How many Ks in one set? 4. 4 times 11, 44. So boom, we have our overflow now. Overflow is 44 Ks followed by not the return address, but the target. We're going to overwrite the return address with the target. And so now we've pretty much gotten all we need to draft this exploit. And so I'm going to go ahead and let's see here. I need Sublime. All right, so here is Sublime Text Editor. And so from here, oh yeah, this is the easiest way to hack binaries is to use something called Pwn Tools, PWNTOOLS. This is Python suite dedicated to hacking into things. And they do a really good job. It's very easy to write. So I'm going to go ahead and from Pwn. Oh, there we go. And then from Pwn, import. Oh, there we go. Uh, Feel free whenever you don't know a little bit of syntax, don't be embarrassed. Use ChatGPT. Keep on moving with your life. All right, so here we go. P equals remote, and then it's going to be the port number and the address. And I'm going to go ahead and exit out of this debugger. Yes, there we go. So what was the port number and stuff? Okay, there it is. So Saturn, boom, 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 copy. Oh, let's make sure it's still running. Yeah. All right. So is it still running? Oh, we have 3 minutes and 30 seconds before it does another one. Instead of using this one and hoping to beat the clock, let's go ahead and restart instance. There we go. All right. Now we got a fresh 15 minutes on this thing. So I'm going to grab this one and I'm going to go back, not there. Yeah, right there. There we go. Boom. All right, so there. I'll go ahead and switch this over to really good Python stuff. So let's call this, oh, there we go, .py on the desktop. All right, so now it's kind of got, I like Sublime Text Editor. It's really nice when trying to figure out syntax issues. All right, and then what was our, yes, our overflow and our target right here and here. I'm going to grab these and put those right there. And then I'm going to put the target, I'm going to cast that to 32-bit, just like that. All right, so now what we have is we have the overflow of Ks and the target. And so the payload that I'm sending against the server to attack it with is going to be the overflow first, followed by the target. And so in your heads, what you can imagine is 44 of these Ks followed by this in binary, blah, 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 whatever it was. And that's what I'm sending to the server. All right, payload. And then I need the program to know when to send this stuff, this payload. And so what I use is, so we've done the remote server, called it p.sendLine after. It's just basically saying, I need you to interact with this program that's about to talk to you over the connection. Yeah, I believe it was string, something like that. There we go. And then once you receive, please enter your string or something similar, a subsection of it. I need you to send this payload in response to this stuff that you get from the program. And then I need you to listen for the response. And I not only need you to listen for the response, I, as the hacker, need to see it. So I need you to print out whatever you receive uh, decoded. There we go. Come on. There we go. Decode. It's been a while since I've done all this, so I'm a little rusty. There we go. And then UTF. There we go. Hey. And then errors place. And really, this stuff right here, you don't have to worry too much about it. Kind of think of this as preamble. So here's the preamble. Here's the post stuff. This right here is the important part. The whole thing for this exploit is the overflow, the amount of number to overflow it, and then what target you want to snap at the end of the overflow. That's the whole thing behind these Stack Overflows. So I'm going to save this. And so now, let's see here. Yep, got that. Good. All right. So now let's see here. Let's do the terminal here. All right. I'm going to go ahead and do, actually, let me make sure that program's on the desktop. Oh, there it is. Boo.py. All right. So I'm going to do Python 3 and shoot it in a tab boo with boo.py. Okay, and there it is. This is the flag. And as you can see, that is not the return address that it has been sending us this entire time, every time we run the program. This is the new address that we told it to after overflowing the buffer and copying that over top of the return address. This is the win address. And therefore, when we get the win address, here's the flag. So I'm going to copy that. We're going to go back here, pump it into here, submit flag. Hooray, you solved the challenge again. And so this is the essence of binary exploitation. All the stuff, it's just, it comes and boils down to just knowing how to reverse engineer a little bit of the binary and then create exploits. If it seems too much, it's really not. Because all it is if you did this 10 times consecutively, by the 11th time, you would know exactly what you're looking for and what you're looking at. All you're looking for is, okay, where can I open the flag? Right here. I need that. where is the return address? Oh, there it is. How many Ks to get there? Slap on that, you're done. It gets really easy after repetition and practice. And they do call these medium level. There are easy ones to kind of start out with. High time, heap, zero format string, things like that. And you don't have to start at binary exploitation. You can start at reverse engineering. You can do the easy reverse engineering, it's the medium ones. And what reverse engineering comes into play, like to help you, is that you kind of get a feel for how these programs work. It does get more advanced, but the purpose of this video was really just to kind of give you two guys, like if you wanted to look into the future and think to yourself, would I be interested in the field? At least now you've kind of seen the foundational pieces, kind of where it leads to. It's all about puzzles. It really is. All that we just did was just one big puzzle and trying to think, okay, how can I trick the computer into doing what I want it to do? And so, if you guys ever have any questions, feel free to reach out through your parents to me. Always go through your parents. And I'd be happy to do sessions, little teaching sessions, things like that. These are, you know, these things are not as hard as they may appear. They may appear alien, but they're not hard. And so I can teach you guys. Anyway, have a good one. Be safe. Do math and science. Get paid. We'll see you guys next, I guess, Thanksgiving.